I'm Dr. Sabnayan, Assistant Professor, Department of Electronics and Communication, Rajagiri School of Engineering and Technology, Kakinad. And I'll be handling the first part of Module 1 under Digital Signal Processing for S5 Easy students. The topics of discussion include discrete Fourier transform or DFT, DFT as a linear transformation, and relationship of DFT to other transforms. We all must have learned about Fourier transform. Okay, so discrete Fourier transform or DFT can be seen as a sampled version of Fourier transform, or you can say that discrete Fourier transform is obtained by sampling the Fourier transform x of e raised to j omega at n equally spaced points over the interval 0 to 2 pi with a spacing of omega equal to 2 pi by n. So as indicated, x of k is equal to sampled version of x of e power j omega for every omega equal to 2 pi by n. And the notations used are as shown. Small letter x of n indicating the time domain, or n is the time index, and capital letter x of k indicating the DFT, where k is the frequency index. So x of k is equal to DFT of x of n, and x of n is equal to inverse DFT of x of k. The endpoint DFT is computed as x of k is equal to sigma n equal to 0 to n minus 1 x of n e raised to minus j 2 pi k n by n for k varying from 0 to n minus 1. The capital N should be selected such that it is greater than or equal to L, where L is the length of the sequence x of n. And inverse DFT, it is computed as given in the equation. Small letter x of n is equal to 1 by n sigma x of k e raised to j 2 pi k n by n for small letter n varying from 0 to n minus 1. Now let's do a problem. So the question is to find DFT of x of n is equal to 1 1 0 0. So what's the length of input sequence? It is 4. Okay, so we have to take capital N such that it is greater than or equal to the length of the input sequence. So here let's take capital N as 4. So what happens to the expression x of k? General expression is given in equation 1. So if you put n equal to 4 in that, you will get equation 2. X of k is equal to sigma x of n e raised to minus j 2 pi n k by 4, or it is equal to sigma n from 0 to 3 x of n e raised to minus j pi n k by 2. Okay, for k varying from 0 to 3. So our aim is to find out the values of output for k equal to 0, k equal to 1, k equal to 2 and k equal to 3. So let's find out the first one, capital X of 0. So you have to substitute k equal to 0 in the second equation. So what happens? E raised to 0 is equal to 1. So the answer is x of 0 is equal to sigma n from 0 to 3 x of n, which is equal to 1 plus 1 plus 0 plus 0, which is equal to 2. Now finding the next term, x of 1 for k equal to 1, okay, which is equal to sigma n from 0 to 3 x of n e raised to minus j pi n into 1 divided by 2. Okay, so you substitute each of the x values and you simplify. What happens? The result is 1 plus e raised to minus j pi by 2 plus 0 plus 0. And what is e raised to minus j pi by 2? It is cos pi by 2 minus j sin pi by 2. And what is cos pi by 2? It is equal to 0. What about sin pi by 2? Sin 90 is 1. Okay, so the result is 1 minus j sin pi by 2, which is equal to 1, or it is 1 minus j. Next we have to find out capital X of 2 and capital X of 3. Okay, so to find out capital X of 2, you have to substitute k equal to 2 in the expression for DFT. So what happens? It is sigma n from 0 to 3 x of n e raised to minus j pi n into 2 divided by 2, or it is e raised to minus j pi n. Now you substitute each of the values from the input sequence, and when you simplify, you will get it as 1 plus e raised to minus j pi. And what is e raised to minus j pi? It is cos pi minus j sin pi. Cos pi is minus 1 and sin pi is 0, or it is 1 minus 1, which is equal to 0. And the last value, capital X of 3. To find out capital X of 3, you have to substitute k equal to 3 in the expression for DFT. So we'll get it as x of 3 is equal to sigma n from 0 to 3 x of n e raised to minus j pi n into 3 divided by 2, or it is sigma n from 0 to 3 x of n e raised to minus j 3 pi n by 2. Now you have to substitute each of the input sequence values, that is for n equal to 0, n equal to 1, n equal to 2 and n equal to 3, and find the summation. So you have to substitute and simplify. You will get it as 1 plus e raised to minus j pi by 2, or it is 1 plus cos 3 pi by 2 minus j sin 3 pi by 2, which is equal to 1 plus j. And so the final answer you have to write in this form: x of k, the in frequency domain x of k, which is equal to each of the values which you have found out. So it is 2, 1 minus j, 0 and 1 plus j. So the final answer should be written like this: capital X of k is equal to, within the brackets, 2, 1 minus j, 0, 1 plus j. Now let's do a problem to find out the inverse DFT. So the question is, find IDFT of y of k is equal to 1, 0, 1, 0. So you are given the DFT value, that is why you have the k index. Okay. So you are asked to find out inverse DFT. We have to find out small letter y of n. So the expression for finding out IDFT is y of n is equal to 1 by n sigma k from 0 to n minus 1 y of k e raised to j 2 pi n k by n, for n varying from 0 to capital N minus 1. So the length of this input sequence is 4. So let's take capital N as 4 again here also. So substituting capital N equal to 4, we will get equation 2. So y of n is equal to 1 by 4 sigma n k varying from 0 to n minus 1 y of k e raised to j 2 pi n k by 4. So on simplification it is e raised to j pi n k by 2. Okay, so we have to find out each of the values in time domain, that is small letter y of 0, small letter y of 1, small letter y of 2 and y of 3. Okay, so to find out y of 0, substitute n is equal to 0 in the equation 2. So what happens if n equal to 0? In equation 2, e raised to 0 becomes 1. So it is 1 by 4 sigma k varying from 0 to 3 y of k, or it is 1 by 4 into summation of the terms in the input sequence. Okay, it is 1 plus 1, which is equal to 2 divided by 4, which is equal to 0.5. Now next value, what is y of 1? So to find out y of 1, you have to substitute n equal to 1 in equation 2. So what happens? It is 1 by 4 k from 0 to 3 y of k e raised to j pi k by 2, since n is equal to 1. Okay, so which is equal to 1 by 4 into, you put each values of y of k in this, you find the summation, and the answer is obtained as it is equal to 0. So similarly you find out y of 2 and y of 3, and the final answer is obtained as y of n is equal to y of 0, y of 1, y of 2 and y of 3, which is equal to 0.50, 0.50. Next is DFT as a linear transformation. So here what we are going to do is, we are going to represent e raised to minus j 2 pi by n as wn. Wn is actually the nth root of unity. Okay, Wn is also called twiddle factor. So we will learn more about this twiddle factor and all in fast Fourier transforms in second module. Okay, so if you represent this e raised to minus j 2 pi by n as Wn, we can get simplified expressions for DFT and IDFT as shown in expressions 1 and 2. So the expression for DFT is x of k is equal to sigma n from 0 to n minus 1 x of n wn raised to kn. Similarly, expression for inverse DFT is small letter x of n is equal to 1 by n sigma k from 0 to n minus 1 x of k wn raised to minus kn. Okay, now what we are going to do is, we are going to represent the input sequence x of n is equal to 0, 1, 2, 3, etc. as an endpoint vector as shown in expression 3. Similarly, we are going to represent the DFT as expression 4. Okay, so the bold in equations 3 and 4 denotes that it is a vector. Next we shall see a matrix Wn as given in equation 5. Okay, so the first row is all 1, then second row first term is 1, then wn, then wn square, etc. up to wn raised to n minus 1. What about third row? It is first term is 1, then wn square, wn raised to 4, etc. up to wn raised to 2 into n minus 1, and etc. It goes on, and the last row is 1, wn raised to n minus 1, wn raised to 2 into n minus 1, etc. up to wn raised to n minus 1 into n minus 1. So using this expression, we can express DFT and IDFT in a simplified manner. Okay, so endpoint DFT may be expressed in matrix form as given in equation 6. That is, capital X of n is equal to this matrix Wn into small x of n. Okay, this Wn is actually a symmetric matrix, means it is equal to its transpose. Okay, so from equation 6, how can you get back the vector, input vector? By taking the inverse. So x of n is equal to wn raised to minus 1 into capital X of n. Okay, so capital X of n is the DFT. Now from the previous slide in equation 2, you can express IDFT as x of n is equal to 1 by n wn star capital X of n. Okay, now you compare equations 7 and 8, then you can get wn raised to minus 1 as, or wn inverse as 1 by n into wn star. Okay, so wn star is the conjugate and wn raised to minus 1, that indicates the inverse. Next is properties of twiddle factor, periodicity and symmetry. Periodicity, that is wn raised to k plus n is equal to wn raised to k, and symmetry, that is wn raised to k plus n by 2 is equal to minus wn raised to k. Now let us consider W4. W4 is e raised to minus j 2 pi by n equal to 4, or it is equal to e raised to minus j pi by 2. What is e raised to minus j pi by 2? It is cos pi by 2 minus j sin pi by 2, or it is minus j. Now using symmetry and periodicity property, we shall find out W4 raised to 7. Okay, so W4 raised to 7 can be written as W4 raised to 4 plus 3, which is equal to W4 raised to 3 according to periodicity property. And this W4 raised to 3 can be represented as W4 raised to 2 plus 1, which is equal to minus W4 raised to 1 according to symmetry property. Okay, so it is minus 1 into minus j, which is equal to j. Okay, next we shall see a problem. The question is compute DFT of x of n is equal to 0, 1, 2, 3. Now let's do using the linear transformation matrix. So we know the general expression for Wn. So from that we shall find out W4. Why we choose 4 as? Because the input sequence is of length 4. Okay, so W4 we write from the general matrix, we can write W4 as shown. Okay, and we have to find out each and every element of the matrix using either symmetry or periodicity or both. Okay, so here in this case W4 is e raised to minus j pi by 2, which is equal to minus j, and W4 square is square of minus j, which is minus 1. W4 raised to 3 is W4 into W4 square, which is minus j into minus 1, which is j. Then other terms we have to find out using either symmetry or periodicity or both. So using those properties we get the matrix W4 as shown, and from the question the input vector x of 4 is as shown, that is 0, 1, 2, 3. And how will you get the DFT? You just multiply the transformation matrix with the input sequence. So it is W4 into x4. So simply multiply the two matrices and you will get the answer as shown, and the final answer has to be written as shown in using the brackets. Okay, next we shall see the relationship of DFT to other transforms. So first is the relationship of DFT to Fourier transform. So Fourier transform of a sequence of finite duration of length n is given as equation 1, x of e power j omega is equal to sigma n from 0 to n minus 1 x of n e raised to minus j omega n, where x of e power j omega is a continuous function of omega, and DFT is given as x of k is equal to sigma n from 0 to n minus 1 x of n e raised to minus j 2 pi n k by n. Now if you compare the equations 1 and 2, we see that the DFT is a sampled version of Fourier transform. Okay, as shown, x of k is equal to x of e power j omega sampled at omega equal to 2 pi k by n. Next, relationship of DFT to Z transform. Now consider sequence x of n of finite duration n with Z transform as shown. X of z is equal to sigma n from 0 to n minus 1 x of n z raised to minus n. And we already know the expression for IDFT, that is x of n is equal to 1 by n sigma k from 0 to n minus 1 x of k e power j 2 pi k n by n. Now if you substitute equation 2 in equation 1, x of z is equal to sigma n from 0 to n minus 1, instead of x of n, substitute the expression from IDFT multiplied by z raised to minus n. Okay, and you change the order of summation. So it is 1 by n sigma k from 0 to n minus 1 x of k, then sigma n from 0 to n minus 1 e raised to j 2 pi k n by n z raised to minus n. Now you group the terms in smaller n together. Okay, now we see that it is a geometric progression, and if you use the expression for summation of geometric progression, you get the final answer as 1 minus z raised to minus n by n sigma k from 0 to n minus 1 x of k by 1 minus e raised to j 2 pi k by n z raised to minus 1. These are my references, and thank you for your patient listening.